Welcome to another incredible edition of Comet Algebra. We have done the law of sines in section 11.1. In 11.2, we're going to do the law of cosines. Now, just to remind you, the law of sines is used when we are given certain information in a triangle. If we're given angle, angle, side, or angle, side, angle, we know we can use the law of sines. Also, we're just going to do one of the ambiguous possibilities. When you're given side, side, angle, sometimes the triangle does not exist because the sides are too short to make a triangle. Or another thing that can happen is that there's two triangles. In Algebra 2, we're just going to deal with the ambiguous case where there is one triangle and it will exist and we'll work with it. And in that case, when you're given side, side, angle, you also use the law of sines. The law of cosines is used when we're given the three sides of the triangle or two sides with the angle in between them. Now, this will just save you some time knowing this. If you start with the wrong one, you will come to a dead end and you'll realize it, and then you'll have to switch to the other one. The law of cosines comes from the Pythagorean theorem, and we did an activity in class to derive it. So I'm not going to go through that on this video. So here's the law of sines, and I did show it written for the three different possible sides of the triangle: little a, little b, and little c. And if you notice, if you're looking for side little a, you're using the cosine of that angle. And then the other two sides are used in the middle part of this formula. So just kind of look at the pattern here. And this is on your pink sheet. So let's use the law of cosines to solve this triangle. And the reason I know that I'm going to be using the law of cosines, because I'm given this side, 40, I'm given this angle, b, and this side, and this angle is in between those two sides. So this is a side angle side, and I'm looking for the other two angles, a and c, and I'm looking for this side b. So let's, because I can't find these angles yet, I would like to use the law of sines to do that because I think it's easier. We could find this side b first and then switch to the law of sines to find the angles. So that's our plan. So finding b squared, we plug in everything to the law of cosines formula. B squared equals 40 squared plus 60 squared minus 2 times 40 times 60 times the cosine of 51. So now it becomes calculator work. Square these two and add them. And when I did that, I got 5,200. And then you have to kind of watch this negative sign. Sometimes when you multiply this out, you get a positive number. Sometimes you get a negative, and you have to watch out for that double negative. In this case, when I multiplied 2 times 40 times 60 times the cosine of 51, I got 3,020.738. So if you subtract that, then we have b squared equals 2,179.262. And please remember, this is b squared, so you need to square root both sides. It's kind of easy to forget that last step. And then rounding off, I just rounded to the nearest hundredth, 46.68. So now we have found angle B. And like I said, you do have a choice. You can use the law of cosines to find another angle here, but why? I think it's easier to just go ahead and switch over to the law of sines. So using the law of sines and setting it up here, we would have the sine of angle A over 60 equals the sine of 51 over little b, which is 46.68. And if we cross multiply, sine 51 times 60 divided by 46.68, we would get that the sine of A equals is 9.9989. So please remember, now this is a backwards problem. We have the sine and we want the angle. So you have to use the inverse sine key on your calculator. And if you do inverse sine, you would get that angle A is, rounded off to the nearest tenth, 87.4 degrees. So now that you have two angles in the triangle, simply subtract from 180 and you'll find that angle C is 41.58 degrees. And now we've solved the triangle. The second example we're going to look at is a triangle where they give us all three sides. So this is a side, side, side. Now you have some choices. What I've done here is, this is side little a, little a is 12, little c is 8, little b is 10. I chose to look for angle A first by plugging in to the law of cosines. Now, if you were going to do this, this is fine. You'd have to square both of these numbers and subtract them over to the other side. Multiply this out, and then this becomes a divide here. Divide by whatever this product is. And sometimes people don't like this because it's a little more algebra. And I think there is an easier way to do this. You could solve the law of cosines for this angle. And that's what I've done here. Instead of doing all the algebra, this is the same law of cosines, except it is solved this time for the cosine of A. So when you're looking for this angle, you can plug in the three sides here, and the two sides that are not across from the angle you're looking for. Like I said, this just makes the algebra easier, that you don't have to do that every time, and that you just have to solve for the angle. So take a minute if you'd like, and you can add this to your pink sheet and use this if you prefer it. So now I'm going to scroll back up and I'm going to use this formula in our triangle. All right, so I put in the B and C here, 10 squared plus 8 squared minus 12 squared, all over 2BC. And then if you do the calculator work with 10 squared plus 8 squared minus 12 squared divided by 2 times 8 times 10, you should get the cosine of A is equal to 0.125. And then if you use your cosine inverse key, angle A would be 82.8 degrees. Now you have some options. We know one angle and we know all the sides. So now you can switch into law of sines if you want to find another angle. And that's what I prefer to do. So if I set this up correctly with the law of sines, sine of 82.8 over 12 equals sine B over 10. Cross multiply and divide, get the sine B, and then do the inverse sine. I got that angle B is 55.8 degrees. And now that you know two angles, you don't have to use the law of cosines or sines. You can simply subtract from 180. And if I did that right, I ended up with that angle C is 41.4 degrees. And then the triangle is solved. All right, have fun with the law of cosines.